Alright, these are the notes for 9/26/17. It's a Tuesday, September 26, 2017. We are doing the notes sheet titled Parallel Lines Cut by a Transversal Notes. So it's important we know these are notes, okay? It says for each of the following sets of lines, you will use the given angles to find the other angles. Lines L and M are parallel, so we can already show that with some arrowheads down here. And it says line N is a transversal. Okay, so I know it's a transversal because it cuts through two other lines. And in parentheses it says it is a line that intersects the parallel lines. That's great. So yesterday we learned some angle relationships, and so we already know some from Unit 1 as well. So check this out. Angle 2 over here is 125 degrees. Let's go ahead and label that up here, 125 degrees. And we know angle 2 and angle 3 are called what? Vertical angles. So if angle 2 and angle 3 are vertical angles, then we know they're congruent. So angle 3 is also 125 degrees. So let's fill that in up here, 125 degrees. Great. And we can see that angle 1 is right next to it. We call that a linear pair. Okay. So angle 1 is not 125 degrees. It's 180 minus 125, which is 55 degrees. So angle 1, 55 degrees. Now, angle 1 and angle 4 are across from each other. Again, we call those vertical angles. So if we know angle 1 is 55 degrees, we know angle 4 is also 55 degrees. So we're going to fill that in. Angle 4 is 55 degrees. Now let's think about angle 4 and angle 5. If you remember from yesterday, there's a name for those angles, and they are called alternate interior angles. They are between the parallel lines, so they're interior. They're on different sides of the transversal, so they're alternate. And if you remember, anything that is alternate in its name, we said was congruent. So that means angle 5 is also going to be 55 degrees. So let's label that up here, 55 degrees. And let's remember angle 6 and angle 5 make a straight line. They're a linear pair. So angle 6, if we do 180 minus 55, it's kind of like working backwards from what we did earlier. We should get 125 degrees. So angle 6 is 125 degrees. Put that up here at the top. And then we see angle 7 is vertical from angle 6. Those are vertical angles, so angle 7 also has to be 125 degrees. We can label that. And we know angle 8 should be equal to angle 5. So technically, angle 8 is 55 degrees. We can fill that in over here. But we're going to add a little something here. What does x equal? That's the question. Okay, so check it out. We're going to take this information over here. Angle 8 we know is 55 degrees, but we know it also equals this box down here, 9x plus 10. So if we know both of those are equal, we set them equal, and we solve it the way we normally solve. We get rid of the loader, minus 10 on both sides. So we get 45 equals 9x. And then we get rid of the 9 by division. So x equals 5. So if we were asking what's x, we know x is 5. So looking at 3 through 8, on number 3 it asks us what angle pair do 1 and 5 make. So if you look at angle 1 and angle 5, they're in the same top left position for both of those intersections, and that's called corresponding. And we remember corresponding starts with the C, so does congruent. Corresponding are congruent. If you look at angle 6 and angle 4, those are both in between the parallels, but it's on the same side of the transversal. So those are called same side interior. And if they're same side interior, again, same sides are supplementary. That's my S rule. Angle 7 and angle 2, you can see those are outside of the parallels, and they are on alternate sides of the transversal. So I would call those alternate exterior. Alternate exterior angles. And we said if they're alternate exterior, alternates are congruent. Okay? So let's make sure we add angles on these. That's what they are. Angle pairs. Alright, number 6. Angle 7 and angle 6 are across from each other. We actually already said this earlier, but if they are across from each other, those are called vertical angles. Vertical angles are congruent. That's how we figured out all those values on there. They're congruent. 7, list all of the pairs of vertical angles. Hint, you should have 4 pairs. And that's where we're going to notice the zigzag. Okay? Now, you can see the way I color-coded it up here at the top. But do you see all the red angles? Angle 2, angle 3, angle 6, angle 7. It's kind of alternating in a zigzag. And all of those are equal to each other. Same thing with the blue angles. They're angle 1, 4, 5, and 8. They're alternating kind of in a zigzag. So anytime you have these 2 parallel lines cut by a transversal, if you know one angle, you can figure out 3 other ones pretty easily. And the other 4 are the supplement. You just subtract it from 180 to figure those out. So notice the zigzag. Number 8, list all of the angles that form a linear pair. Okay, so if I was going to do number 7 and number 8, all of my vertical angles would be angle 1 and angle 4, angle 2 to angle 3, angle 5 is congruent to angle 8, angle 6 is congruent to angle 7. Those are all my vertical angles. And then down here, for all my linear pairs, we're going to have 8 pairs. It's going to be a lot. 1, 2, 3, 4. 4 on each intersection. So, angle 1 and angle 2, angle 2 and angle 4, angle 4 and angle 3, angle 3 and angle 1. We also have angle 5 and angle 6, angle 6 and angle 8, angle 8 and angle 7, angle 7 and angle 5. Any 2 angles next to each other that form a straight line are called a linear pair. So we have 4 verticals, 8 linear pairs. And that'll do it for this 1 page of notes, but you're going to be doing something very similar on the assignment. It is 2 pages. One side is a puzzle, and the other side is you finding out the missing angles. Don't forget the zigzag pattern. It's kind of an easy way to figure out a lot of stuff. And naming the relationships is important. You might need to look back to yesterday's notes to get all that as well. If you missed yesterday, you can get the notes from the teacher, and you can also fill them in using yesterday's YouTube video. Check it out at YouTube, #MRGLEE, Mr. G Lee.